In my most recent video, we talked about a tap. No, not this tap, the RF tap. The tap joke's getting a little bit old now, isn't it? What ended up happening is I needed a minus 70 dB attenuator, and what I had was a minus 40 because I made some errors. So link to that video below. So what I ended up doing was I took an attenuator that I already had, which was an inline attenuator, designed for 10 watts, and it'll go 0 to 3 gigahertz according to the advertising. Now, I do not have the resources to test the 3 gigahertz, nor do I play around with the black arts of VHF, UHF. But what I will do is I'm going to check this from 1 megs to 200 megahertz. Just see how flat a response I get for the 40 dB. I'm not expecting miracles. I'm really interested in how it performs at the HF level more than anything else. So we'll do a 0 to 30 attenuation check, and then I'll do a recal. I won't show you the recalibration, but rest assured I have calibrated the instrument, and we'll have a look at how flat a response we get from 1 to 200 megs and see whether it is in fact a 40 dB. Now, the reason why I'm doing this is someone actually put a comment on my video saying that they'd bought one of these and it was actually minus 60 attenuation. So it'll just be interesting to see how it performs. And I really should be checking this stuff rather than taking it at face value, because we all know we get some real gems from China. We get some really good stuff, and then some stuff arrives and it's absolute garbage, and we shouldn't just be accepting what's written on stuff at face value. Okay, folks, the nanoVNA, an absolute game changer. If you like to play with antennas and want to understand what's happening on an antenna, if you want to check filters, if you want for roll-off, if you want to check attenuation, this is a fantastic device to have, along with the Ultra SA. You know, you're looking at $300 or $400 outlay for stuff that would have cost you tens of thousands of dollars in the past. And it means that you can really deep dive technically and teach yourself a lot of stuff. And I'm just loving having this gear. And I'm by no means an expert and probably not the right sort of person to be working in any area that requires accuracy. Coming from a fine art background, you probably see I'm a little bit fast and loose with a lot of stuff I do. But when I can be responsible, I try to be. And so what we're going to be doing now is we're just going to be testing this Chinese attenuator. Now, I can't check it to 3 gigahertz. I don't have a signal generator that'll do that, or test equipment. I could probably test attenuation on the Ultra. That'll get up into the gigahertz. Don't know how accurately, but really what I'm worried about is HF. So I'm going to test this because I use this at 7 megahertz. So at 7 megahertz, is it 40 dB? How close is it to 40 dB? So we have calibrated this for 1 to 30, so we should be fine for that with all the proper testing, including the through test, using these leads in the test setup. So we should be accurate on that front. So we'll just plug this attenuator in, and we'll have a look at just what it's up to. So this is on the 1 to 30 megs. Okay, from 1 meg through to 30, we have a minus 38.3 dB. So pretty on the money. And as we head up to 30 megs, we're looking at closer to 39. In fact, we do hit 39 dB. So that is pretty damn fine. So it's nice to know that it's accurate on that front. We'll do a quick recal, and I'll come back for the 1 to 200 megahertz measurement on this device. And here we are, folks, for 1 meg to 200 megs, calibrated, like I said, with the leads in, and it's fairly flat from 1 to 200. 39 point something dB right across the scale. So that means I can pretty much trust this device. In fact, yeah, it's anywhere from 39.9 minus 39.9. So it's less than a dB change, quite a bit less than a dB of change, so flat. That is really great news. So this attenuation in this through attenuator, at least at these very, very small wattages we're talking about that are coming out of the nanoVNA, it's working now. 10 watts, who knows? This is the thing about testing. It's not being tested at the wattage that it's intended for. It might vary wildly when you start putting larger amounts of power through it, but certainly for my situation where I was only taking a few milliwatts out of the RF tap, pretty much like for like in this situation. So this tells me that I'm probably pretty close to the money when it comes to what I'm actually measuring, which is nice to know. Now it's that point in the video where I'm going to ask you to reach down, hit that like or the dislike, and if you do like, maybe think about hitting the subscribe button. I'm going to keep doing this regardless of how few subscribers I do have, but it would be really nice to have a few more subscribers. We all thrive on external validation. Well, not all of us, but I certainly do. So there you have it, folks. The attenuator from AliExpress, 10 watts, 1 to 30 gigahertz. We now know has a flat response from 1 to 200 megs, which is nice to know. Probably should have checked it at the start. The plan is eventually to make my minus 40 dB RF tap minus 70 on its own, but we now have a situation where we can test up to about minus 70 anyway in combination by using these two together. So I probably should have done that at the start, because if this was wrong, all my measurements would come into question. But we all know that the Tiny SA and the nanoVNA are reasonably accurate for a hobbyist. Obviously, if you're an RF specialist, you'd need to spend a bit more money, but it's really nice to know what's going on. Once upon a time, a lot of this stuff would have been very abstract for a hobbyist. You wouldn't know what sort of reactance and impedance was happening on your antenna. It would be very difficult to ascertain that. We've now got so much very, very high-tech, very high-resolution stuff at our disposal. And so the fact that the hobby is kind of moving away from the technical aspects raises a really giant in my head, because people, get out there, have a go at this stuff. If an artist, failed engineering student like me can get you their head around this stuff, a lot of you can also do that. And I can honestly say, once again, I hate to proselytize, but I can honestly say that having a go at this technical stuff, building some kits, getting a greater understanding of the technical aspects of the hobby just increases the interest, makes it so much more fun. And I love this hobby. I'm very passionate about the hobby, and I want you to be too. So if you can afford it, I certainly would suggest grabbing a nanoVNA and watching all the plethora of videos that are available on how to use that device. It'll help you out no end. And build a kit. Just build a kit. Build a transmitter. See how you feel about what happens as a result of that. I'm certain that many of you will get the bug and will be away on your home brewing journey. 7-3, and I shall see you in the next episode of The Art of Engineering.